Myself, Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering. In this session, I am going to discuss about lead acid and lithium ion batteries and their applications. In this session, I am going to cover what is the construction of a lead acid battery, working and its application, and lithium ion battery and its applications. So, first one is lead acid cell. So, lead acid cell battery was invented in 1859 by French physicist Gaston Plante. Gaston Plante. This was invented in 1859 by French physicist Gaston Plante. It is a secondary battery. It is a secondary battery. So, what is secondary battery? Secondary battery is a rechargeable battery, and the electrode reactions in this battery are reversible. Electrode reactions are reversible, and these batteries are meant for multi-cycle use, not for single. This can be used for multi-cycles. So, this is a secondary battery. This is the example of secondary battery, that is lead acid cell. So, here lead acid cell. Lead acid cell. So, every cell having anode, cathode, electrolyte solution. In this lead acid cell, anode and cathode is made up of lead. Anode is cathode and anode are made up of lead, and the electrolyte is acid. The electrolyte is acid. So, anode is lead. Anode is lead. Anode is lead. Cathode is lead oxide. Lead oxide. So, that is PbO2. Electrolyte is sulfuric acid. Diluted sulfuric acid, H2SO4. H2SO4. So, these two are lead compounds, and this is acid, that is H2SO4, sulfuric acid. Diluted sulfuric acid means, so we are diluting this acid with water. Diluting this acid with water. So, here lead acid cell means lead, the anode is lead, cathode is lead oxide, electrolyte is acid, that is diluted H2SO4. The EMF of this lead acid cell is 2 volts. 2 volts. So, here lead, this is lead anode, this is lead oxide cathode, and these two are placed in the diluted H2SO4, that is electrolyte. That is electrolyte. So, this is the lead acid cell. Lead acid cell. So, lead acid cell, this consists of number of Pb plates. This consists of number of Pb plates. So, like this, these are connected in parallel. These are connected in parallel. And also, the number of PbO2 plates are connected parallel, connected in series or parallel. So, these are Pb plates, these are PbO2. PbO2. So, these Pb plates, they are anode, this having negative charge, cathode having positive charge. So, cathode is having positive charge. So, lead and lead oxide are connected in parallel like this. So, this Pb is connected to positive terminal, PbO2 is connected to negative terminal of the cell. These two are separated by one insulator. These two, anode and cathode, are separated by insulators. So, such as wood, fiber, glass, rubber. Wood, fiber, glass, rubber. These are the insulators. These anode and cathode are separated by these insulators. And the entire is placed in H2SO4. H2SO4 electrolytic solution. H2SO4 electrolytic solution. How much percentage? 20 to 21 percentage of H2SO4. 20 to 21 percent of H2SO4 means if we take 20% of H2SO4, how to make this? How to make this? First we have to take one measuring cylinder. So this is 100. This is 100 ml quantity. In this, so some are there. If it is 20, so first we have to add 20 ml of acid. 20 ml of acid. 20 ml of acid to the measuring cylinder, and we have to make up to 100 ml with water. Make up to 100 ml with water. So that is called as 20% H2 diluted H2SO4. Means here we are using 20 ml of H2SO4 and plus 80 ml of water. 80 ml of water. So by mixing these two, water and H2SO4, we are getting the respective percentage of H2SO4 solution. So we are having PB and PbO2 plates, and these are separated by some insulating material, that is wood, fiber, glass, rubber, and these electrodes are immersed in the diluted H2SO4, that is 20 to 21% of diluted H2SO4. This is the construction of lead acid cell. So what working of lead acid cell? So we know that at anode oxidation is taking place. At anode oxidation takes place. At cathode reduction takes place. At cathode reduction takes place. In this lead acid cell, we are having anode and cathode and electrolyte. So at anode, what is anode? Here we are having two electrodes. One is lead, other one is lead oxide. Lead oxide. So this is negative charge, this is positive charge, this is anode, this is cathode. This is cathode. So at anode, what is anode? Lead is anode. So this can undergo oxidation. Lead can undergo oxidation and forms lead ion, 2 electrons. Lead ion and 2 electrons. This lead plus 2, Pb plus 2 ion again reacted with SO4 minus 2 ion, which is present in electrolytic solution, and form PbSO4 precipitate. PbSO4 precipitate. So what is the net reaction at anode? So Pb plus this cancelled out, SO4 minus 2 gives rise to PbSO4 precipitate plus 2 electrons. Plus 2 electrons. This is the reaction at anode. So lead is undergoing oxidation and forms lead plus 2 ion, and this is again reacted with the sulfate ions which are present in electrolytic solution, and this is forming lead sulfate precipitate. So total net reaction is lead plus SO4 minus 2 gives rise to PbSO4 plus 2 electrons. So at cathode is, we are having cathode PbO2, and we are having an electrolytic solution for H plus ions and 2 electrons. This can undergo oxidation. Pb can undergo oxidation, reduction, and forms Pb plus 2 plus 2H2O. So at cathode reaction takes place, this PbO2. In this PbO2, here what is the oxidation state of Pb? Here oxygen is having for one axis oxygen -2. We should take -2. For 2 oxygens, here -4. So this is +4 oxidation state. The oxidation state of Pb in PbO2 is +4 oxidation state. So in this Pb is Pb +4. Pb plus 4 is converted into Pb plus 2. means it is undergoing oxidation. By taking 2 electrons, it is forming Pb plus 2 ion. So here Pb is undergoing reduction at cathode. Pb is undergoing oxidation at cathode. This Pb plus 2 reacted with the sulfate ions which are present in electrolytic solution and forms PbSO4. PbSO4. So what is the net reaction here? Here Pb cancelled out. Here PbO2 plus SO4 minus 2 plus 4H plus 2 electrons gives rise to PbSO4 plus 2H2O plus 2H2O. This is the net reaction at cathode. Net reaction at cathode. So, what is the net reaction of cell? So, for this we have to add both the cathodic reaction and anodic reaction. Anodic and cathodic reaction. Here, this is one reaction. This is, by combining this, we can get Pb plus PbO2 plus here one SO4 minus, here another one SO4 minus. So we are having 2 SO4 minus 2 ions, 2 SO4 minus 2 ions and 4H plus. 4H plus in this, and these electrons are cancelled out, and it gives rise to Pb, 2 PbSO4. Here 1 PbSO4 is there, here 2 PbSO4 precipitate is there, so we have to write 2 PbSO4 plus 2H2O. 2H2O plus energy. 2H2O plus energy. So why we are writing here energy? During discharging, lead acid battery acts as electrochemical cell. Electrochemical cell means chemical energy is converted into electrical energy. The cell in which chemical energy is converted into electrical energy is called as electrochemical cell. So during discharging, lead acid cell acts as electrochemical cell. So here we are writing this reaction with energy, means here energy is releasing. What energy? Electrical energy. This is the net reaction. Pb plus PbO2 plus 2SO4 minus 2 plus 4H plus 2 PbSO4 precipitate plus 2H2O and energy. Here chemical energy is converted into electrical energy during the discharging of lead acid cell. So it can act as an electrochemical cell. During charging, it can act as electrolytic cell. Battery can act as electrolytic cell. What is electrolytic cell? In this, electrical energy is converted into chemical energy. Electrical to chemical energy. Chemical energy. So at anode, oxidation takes place. At cathode, reduction takes place. Here during charging, so by supplying electrical energy, the electrode reactions can be reversed. This is a secondary battery, so the electrode reactions are reversed. The electrode also reversed. At anode, what is happening here? Pb plus 2 plus 2H2O gives rise to PbO2 plus 4H plus 2 electrons. So here Pb plus 2 is converted into Pb plus 2 is converted into PbO2. Here plus 4 oxidation, here plus 2 oxidation. So plus 2 is converted into plus 4. Means it is undergoing oxidation. It is undergoing oxidation. So the Pb is undergoing oxidation at anode, and this is the reaction of this lead acid cell at anode. Again, so at anode, we are having lead sulfate salt. Lead sulfate salt, that is converted into Pb plus 2 plus SO4 minus 2. Again, it is divided into Pb plus and SO4 minus 2 during charging. So this is the Net reaction at anode during charging. Here PbSO4 plus 2H2O gives rise to PbO2 plus SO4 minus 2 plus 4H plus 2 electrons. It is the net reaction at anode. At cathode, what is happening? Pb plus 2 undergoing reduction and forms Pb, and this again we are having at cathode PbSO4 precipitate, that is again converted into Pb plus 2 plus SO4 minus 2. So net reaction is PbSO4 plus 2 electrons gives rise to Pb plus SO4 minus 2. Pb plus SO4 minus 2. The net reaction at in the cell, lead acid cell, during the charging is, so first we have to combine the reactions at anode and cathode. So here we are having one PbSO4 and another PbSO4. So 2 PbSO4 plus 2H2O plus energy. Here we are using electrical energy. So I am writing Ne symbol, Pb plus PbO2 plus 2SO4 minus 2 plus 4H plus 4H plus. So these are the reactions during the charging. So at both the cases, at anode oxidation is taking place, at cathode reduction is taking place. But during charging, the electrode reactions are reversed. So this is the reaction during charging. This is the reaction during charging. In this Pb plus PbO2 plus 2SO4 minus 2 plus 4H plus gives rise to 2 PbSO4 plus 2H2O energy. In this, by using energy, this PbSO4 and water converted into Pb and PbO2 plus 2SO4 minus 2 plus 4H plus. If we observe these two reactions, during the discharging, H2SO4 is consumed. Here 4H plus 2SO4 minus 2 means H2SO4. In this last H2SO4, it products at H2SO4. During discharging, H2SO4 is consumed. Its concentration is decreases. During discharging, H2SO4 consumed for the reaction. So the concentration of H2SO4 decreases in the cell. So whereas during charging, H2SO4 concentration is increases because the regeneration of H2SO4 is taking place. So the variation of concentration of acid, and hence the extent of discharge or charge of the cell can be easily monitored by the specific gravity of the acid. Here in the discharging reaction, H2SO4 is consumed, so the concentration of H2SO4 decreases, whereas in charging the concentration of the H2SO4 increases because it is regenerated during the charging. So we can easily monitor the reaction by using specific gravity of the acid. During charging, specific gravity of H2SO4 increases. During charging, specific gravity of H2SO4 increases, whereas during discharge, specific gravity decreases. Means concentration decreases, specific gravity also decreases. So, if we know that the voltage of this lead acid cell is 2 volts. The voltage of lead acid cell is 2 volts. So, in general, lead acid cell consists of 6 cells. 6 cells which are connected in a series. Here we are, each cell having 2 volts, it is having 6. So, we can get 12 volts from the lead acid cell. Commonly used lead acid battery it will give 12 volts. 12 volts. So applications of lead acid cell. These lead acid batteries are used in telecommunication and power stations, television systems, standby supplies like UPS uninterrupted power supplies, and it can be used in electrical vehicles, emergency lights, which are used in hospitals like that, and which are these lead acid batteries also used in railway mines. These are used in telecommunication, power stations, television systems, standby supplies, electrical vehicles and emergency systems, emergency lights and railway mines. So these are the applications of lead acid cell. Next secondary battery is lithium ion battery. Lithium ion battery is a secondary cell. It can be recharged. In this also electrode reactions can be reversed. And this can be used for multi-cycles. Used in multi-cycle usage. So in this lithium ion battery means here anode, cathode and electrolyte. Anode, cathode, electrolyte, three are made up of lithium. So anode is lithium doped graphite. Cathode is intercalated lithium compound. Such as layered lithium cobalt 3 oxide, that is lithium CO2. Electrolyte is lithium hexafluorophosphate. Which is dissolved in dimethyl carbonate. So three are anode, cathode, electrolyte. Three are made up of lithium ions. So anode is lithium doped graphite. Graphite means it is a allotrope of carbon. So it is nothing but carbon. Lithium doped graphite means an intercalated lithium compound. So both intercalated lithium compound and both doped lithium is means insertion of lithium ions into the layers of different materials. If we use graphite, doping means lithium ions are inserted in graphite layers of graphite like this. Layers of graphite like this. Whereas intercalation also insertion of lithium ions into the layers of that cobalt oxide compound. So both intercalation and lithium doping are same, but in the case of doping, charge transfer takes place, but in intercalation only insertion takes place, not charge transfer. So this is the difference between doping and intercalation of lithium compound. So here anode is lithium doped graphite and cathode is lithium intercalated lithium compound such as layered lithium cobalt 3 oxide, that is lithium LiCO2. The electrolyte is complex lithium compounds such as lithium hexafluorophosphate, lithium PF6, lithium hexafluorophosphate, dissolved in dimethyl carbonate solvent. So these batteries provide lightweight, high energy density power sources for variety of devices. Lightweight, high energy density power sources for variety of devices. So here anode is lithium doped graphite, cathode is intercalated lithium compound such as layered lithium cobalt 3 oxide. These are separated by insulating material insulator such as wood glass rubber. In this electrolyte is lithium hexafluorophosphate, which is dissolved in dimethyl carbonate. So lithium ion battery reactions, working of lithium ion battery. So working at anode, oxidation is taking place, cathode reduction is taking place. So at anode, what is anode? Lithium doped graphite. Lithium doped graphite. Here I am writing lithium ions name, n number of lithium ions doped in carbon. So here I am writing lithium Nc. This is the anode. This can undergo oxidation and forms N lithium plus N electrons plus carbon. Here this is the reaction takes place with anode. It takes place at the anode. At anode, anode will undergo oxidation. What is anode? Lithium doped carbon, which lithium doped graphite. Here I am writing L lithium Nc, which is undergoing oxidation and forming lithium ions and carbon. So at cathode, here we are taking lithium CO2 as a cathode. Here 1 minus N lithium CO2 plus N lithium ions, which are came from the anode and form N electrons, gives rise to carbon. So, lithium CO2. This is the reaction takes place at cathode. So what is the net reaction at cathode? During charging and discharging. So during the discharging, first we have to combine this lithium Nc plus lithium 1 minus N CO2 plus this can be cancelled out and gives rise to C plus lithium CO2. This is the cell reaction during the discharging. So during charging, the electrode reaction is reversed. So we have to write in reverse. C plus lithium CO2 gives rise to lithium carbide plus lithium intercalated compound CO2. This is the reaction during the charging. So at anode, oxidation is taking place. Here the compound, the graphite, which is doped with lithium ions, undergoing oxidation and forming lithium plus ions. These lithium plus ions again reacted with the cathode and forming lithium CO2. And the cell reaction during the discharging is this one. And during charging, the cell reaction is reversed. So we have to write in reverse manner. So this is the cell reaction during the charging. C plus Li lithium CO2 gives rise to lithium Nc plus lithium 1 minus NCO2. This is the working of lithium ion battery. Applications of lithium ion battery. So where we can use this lithium ion batteries? These can be used for portable electronics and electrical vehicles and are growing in popularity in military and aerospace applications. This can be used in portable electronics, electric vehicles and military and aerospace applications. This lithium-ion battery usually used in mobile phones, notebook, PCs, cameras, camcorders, MP3, etc. And also used in power tools such as cordless drills, sanders, saws, and variety of garden equipments, including whipper snipper, hedge trimmers. whippersnipper hedge trimmers. This can be used in power tools and also used in garden equipment. And secondary non-aqueous lithium batteries. Secondary non-aqueous lithium batteries provide reliable backup power to the load equipment in a network environment of telecommunication provider. Means it can be used telecommunication also. It is used in military, aerospace applications, portable electronics, and also used in electric vehicles, and also used in telecommunication, cameras, mobile phones, and laptops, and also used in power tools and also garden equipment, including whippersnipper and hedge trimmers. So these are the applications of lithium-ion battery. So advantages and disadvantages of lithium-ion battery. What are the advantages and disadvantages of lithium-ion battery? So advantage of lithium-ion battery, first one is it is lightweight battery, and it have higher energy density than other rechargeable batteries. This is having higher energy density than other rechargeable batteries. Rate of charge loss is less. Have a greater number of charge and discharge cycles. Discharge cycles means it can be used in multi-cycles and need not be discharged completely. It operates at high voltage than other batteries. These are the advantages. And disadvantages, it involves the risk of bursting. And it is very cost compared to other batteries. The price of lithium battery is more than other batteries. The complete discharge damage the battery. If it is undergo complete discharge, that can damage the battery. Extremely sensitive to high temperatures. It is extremely sensitive to the high temperatures. It is having very short lifespan and not available in standard cell sizes. It's not available in standard cell sizes. So these are the advantages and disadvantages of lithium-ion batteries. So what is the differences between lithium-ion battery and lead-acid battery? So both are secondary cells, both are secondary batteries, both are rechargeable and used for multi-cycle purpose, and electrode reactions also reversible. But what are the major differences between lithium-ion and lead-acid batteries? So for that, lithium-ion battery is more expensive than lead-acid battery. It is cheaper. It is more efficient, and the lead-acid battery is less efficient than lithium-ion battery. The weight of lithium-ion is very less, and the lead-acid battery is heavier and larger. It can store more energy and it can store less energy. So longer expected lifetime. So lifespan of this battery is somewhat better than this lead acid battery, means shorter expected lifetime for lead acid batteries. For charging and discharging, there is need of certain controller. For charging and discharging, they need a certain controller. For lead acid battery, no need of any controller. Lead acid battery, no need of any control. So lithium battery more expensive, it is very cheaper, it is more efficient and less efficient. It is lighter in weight, heavier in weight, and it can store more energy. Lead acid battery can store less energy, and this is having longer expected life, and lead acid battery having shorter expected lifetime. This needs a controller, certain controller, but lead acid battery need not use any controller. So this is about differences between lithium-ion battery and lead-acid battery. And thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.